This is part 2 of a lesson on factoring from 14.6, and on this one we'll cover factoring out the greatest common factor. You will need the class notes for 14.6, not the key, and also the class practice for 14.6 in order to best follow along with this video. Let's do a quick review. A strategy for factoring: the first thing you do is always factor out the greatest common factor. After that, you look at special cases, which we will look into in the next video, and that has to do with identifying perfect square trinomials. After that, you see if your lead coefficient on your trinomial is a 1, and if it is, you use reverse FOIL, and after that you check if your lead coefficient is something other than 1, then you use grouping, and if you have 4 terms, you use grouping. So that's a quick review. And on page 2 of the class notes, we are going to work this problem, and this problem, and we're going to look at this one, and we are going to work this one, and also start working that one. So here we have a binomial, and our first question is there a greatest common factor? In other words, is there a factor that will divide into both of these terms? And the way you do this is easy. You can see it's 4MP, but let me go over the way you can do this if it isn't so easy. You write down the first coefficient and you break it down to its base, its prime, with exponents, and then do the same with your second. Okay, and then go ahead and write out what's left on each term. And now you circle the ones that have the smallest coefficients. So you circle the unique occurrence of each base. For instance, 2 is shown both here and here, and you circle the one with the smallest coefficient. Same for M, same for P. And what you have left in this case is 4MP, which is this, and that's what you're going to use as your greatest common factor. Okay, now you are going to write 4MP, and then you're going to write what you have left. So how do you figure out what you have left? Well, the way you do that is you actually divide. So let's go back to our original expression. If we divide each of these by 4MP, then what we get in our first case is 4 goes into 8 2 times, M goes into M squared once. Remember, you subtract the coefficients, and P goes into P squared once. And over here, everything cancels, leaving you with 1. So what you have left are 2MP plus 1. So it's very important that you don't forget to write your greatest common factor in front of this. You cannot factor this any further. There are no more common factors. It's not a trinomial or a special case. So this is the complete factorization of this problem. And to check your work, you distribute your 4MP and you get 8M squared P squared plus 4MP, which is what you started with. Here's the second problem we're going to work, and we're going to work it because there is a greatest common factor. If you have a binomial, you need to have parentheses around it for this to be true. If the binomial is identical to another binomial, then they are the same, and that means this expression has the greatest common factor of A plus B. So we write that down, and then we find out what's left. Well, the way we do that is we divide everything by a plus b in both cases. And because binomials in parentheses are the same unit, they cancel out, and we are left with 5x minus y. And then we examine that and see that we can't factor that out any further. So that is the factorization of number 2. And number 5, here's a case where you look for a greatest common factor, and actually you won't find one. Now you have to be careful with this, because these two terms both have a 7, but this one doesn't, so it's not a common factor. And these two terms both have a 3, but this one doesn't because it's not a common factor. But what if they did have a common factor? Before you factor it out, you want to do a quick check to see if you have any perfect squares. Well, 49 and 9 is a perfect square. Their roots are 7 and 3. 7 squared is 49, 3 squared is 9. So you ask yourself, if 2 times 7 times 3 equals 42, and it does, so then you have a perfect square trinomial, which we'll tackle in a moment. Now let's move on to number 8. In number 8, you do have some common factors. You have 2 goes into each term, and you have z goes into each term also. And you can tell this easily without writing anything down, because all of these are even, and you see z represented everywhere. So you write down 2z, and then you divide everything by 2z. And what you have inside the parentheses is 28 divided by 2 is 14, and z cubed divided by z is z squared. In the second term you have 3z, and in the third term you have 5. Okay, after you've done that, then you need to see if you can factor this term, and in this term you would try to do grouping because it's not a perfect square, there are no more common factors, and there's a number other than 1 in front of the z squared term. So we're going to come back to that. And the last one we're going to look at is number 12, and so see if you can pause this video and find the common factor. Common factor is the binomial d minus 3. So we write the common factor, and then we divide everything by the common factor. And what are we left with? We are left with d plus 7 plus, don't forget that plus, it's not multiplied, d minus 1. And so then when we combine like terms in our second term, we get 2d plus 6. And then we look to see if there are any common factors. Well, there's a 2 here that we can pull out of this one. So we're going to pull it out front, and we're going to keep our first common factor. And when we divide 2d by 2, we get d. And when we divide 6 by 2, we get 3. And that's our final answer. Now look at your 14.6 class practice, and the places we can pull out common factors. Let's look at them. Not 1, not 2, but number 3 we can pull out common factor. Not 4, not 5, not 6, and not 7 or 8. 9, it doesn't look like we can, and 10 we could, but this is a case where we want to be careful, because if we pull out an 8 from that, we'll be left with 8 times parentheses w cubed plus 8. And that would work too, because our w cubed plus 8 is a sum of cubes, and so we can solve that using the sum of cubes. So we'll go ahead and pull out the 8 here and get it done with. So we have w cubed plus 8, and then we'll come back to that later in a little bit when we're talking about special cases. So let's go ahead and look at number 3, and what we want to do, I'm going to take it step by step. First, let's look at the coefficients 18, 24, and 12. 18 is 9 times 2, which is 2 times 3 squared. You can use the factoring tree if you need to. 24 is 3 times 8, which is 3 times 2 cubed. And 12 is 4 times 3, which is 2 squared times 3. So we circle, we look for the same occurrence of each thing. So let's look at the base 2. It shows up here, here, and here. So we're going to circle the one with the smallest exponent. For 3, it shows up here, here, and here. We circle the one with the smallest exponent, and since there are 2, we only circle one of them. And then that's all the bases there are. So we can see that the least common factor has a coefficient of 2 times 3, or 6. And then we look at our m to the 5th, m to the 3rd, and m to the 6th. And we circle the one with the smallest coefficient. So our least common factor is 6m to the 3rd. So we write 6m to the 3rd, parentheses, and then divide each of these by 6m to the 3rd. And for our first term, we get 18 divided by 6 is 3. M to the 5th divided by m to the 3rd. You subtract the exponents and get m squared. Second term, 24 divided by 6 is 4. And the m's actually go away here. They cancel out. And in the third term, we have 12 divided by 6 is 2. M to the 6th divided by m cubed is m cubed. So now we look at these and see if we have any remaining common factors, and we don't, so we know this is our final answer. And that completes our study of the greatest common factor. Now go on to the next video, which talks about the special cases.